Hi. In this video, I want to talk about a recent discovery of mine where plotting via Python inside of RStudio now works as I would have expected. Well, almost works as I would have expected. This is really exciting for me as I think RStudio is the best data science IDE that I've come across. I sometimes have a love-hate relationship with VS Code. I'm not a big fan of notebooks. I know that in the data science world, everyone would roll their eyes at that. But I grew up writing scripts, and I like the interactivity of how to build my programs and scripts and flows all just through an interactive REPL. And RStudio really, when RStudio hit the landscape, really elevated my R skills, and I've always had a strong affinity for what the product has done. Moreover, with R Markdown itself, I feel like there's nothing in the Python ecosystem like R Markdown. But again, prior to what I just noticed, I never would even consider RStudio because I couldn't generate basic plots. Now, when this first came out and RStudio Desktop was touting Python and plotting, it was very basic matplotlib. I've tweeted about this a few times. I think that's great, but I think a lot of people, especially in a teaching context, would create plots from a pandas data frame or use something like Seaborn. And what I want to do today is I want to highlight how we can finally plot inside of RStudio. And I'll close this video with some commentary on why I'm really excited for what this means for data science programming in general. Okay, first of note, I am on R version 4.1.1. And for RStudio, where am I at about RStudio? I am on release 2021.09.0 build 351. Now, at the time of this video, this is a preview release, but I want to highlight this because I am on these versions and I'm also on a MacBook. Okay, so what I'm going to do here is I'm going to create a new Python script, and you can see all these options, which are phenomenal. Again, I'll talk about that in a moment, but I'll create a new Python script. But before I actually do anything, what I want to highlight here is that under the global options, we have the ability to set our default Python interpreter. And in my case, I use Miniconda or Conda, and I have created an environment called RStudio. Now, I like to do this on my machines because when I'm using RStudio for Python, I can just keep it very nice and simple. Now, of course, this could be specific to your project, but for now, I'm just trying to keep it simple and have all my Python utilities via this RStudio environment. Okay, so let's go through some imports. I'm going to import pandas as PD. I'm going to import NumPy as NP. I'm going to import Seaborn as SNS as standard, of course. And then finally import matplotlib.pyplot as PLT. And I'll comment on that, or you'll see why I do that in a moment. Now, when I run this line here, you can see that Reticulate fires by default, and it knows how to correctly use our default global option for our environment. And now you can see that pandas has been imported. Now, what's really cool on the right-hand side here, of course, is that we now see that we have pandas imported. So you can actually see in the environment tab, well, we can manage our environment. I struggle with this when I teach to try to help students understand what is loaded in their environment. I always thought that this was a great feature of RStudio. Tools like Spider attempted to do this, although I don't particularly like Spider as an IDE. I've always struggled with it. It's lacking in VS Code. So from a teaching perspective, I find this to be very helpful for students to see what data objects are loaded in memory. Okay, so let's go through the rest here. And let's create an array. So I'm going to create that array. I'll just call it A. And I'm going to start with NumPy NP, and I hit dot, and you can see that it's starting to do some help for us, which is great. Let me start to do random, and then let's do random int. And when you see I have random int, you can see that we have some help there, which is really nice. However, when I do the parentheses and hit tab here, there's no help or autocompletion like you get inside of R. Maybe that's coming in the future. I think it'd be very helpful. But for now, at least if we remove the parentheses, we get some help there, right? So let's do this. Let's say 0 to 11, and then size will equal 10. That should be tuple 10 by 2. And let's close that out and run that. And when I run that, of course, you now see that it didn't yell us in the interpreter here. We now, inside of the environment, see that we have our array and it prints out. I'd like this to collapse on us, or for us, I guess, but it's kind of cool that you can see that. If you click on that here inside of RStudio, we get all sorts of the data there in terms of the array and the values and the arguments and methods and things. But then let's make this a data frame. You can see here we get some help again. Type A. And now we have our data frame. And when we click on this, we can now see that data frame, and this is the collapse I was referring to a moment ago, right? So we have our data frame there. Again, really helpful for teaching. If we hit dot, let's look at something like shape. We get our 10 by 2 shape here. Let me move this up a little bit. But we get some future warnings. Let me show for pandas. I am on version 1.2, which I think is a minor version behind where pandas is currently right now. Okay, but the whole point of this video is that I really would not recommend to my students using RStudio because of just the basic plotting and what you might do for plotting inside of a pandas data frame or something like Seaborn. So let's create a basic plot. Right? Very basic plot. And we can just simply use the plot method and say kind equals scatter. And let's run that. Well, it requires an x and y axis. Of course it does. So let's say x is equal to x and y is equal to y. But what I should have done up above here is created the columns. So run that again, and you should be able to see x and y now. Okay, so when I run that, you see that we have this axis subplot. This is why we imported plot. So we can actually show our plot. And you can see that it renders here inside of our plot window. And this is exactly what I was looking for, was to be able to generate these arbitrary plots, not using direct matplotlib code, and have that render inside the plot window inside RStudio. This is exactly what I was looking for and gives me so much hope for using RStudio as the data science environment, or at least for R and Python. And I know other languages as well, but in my case, in teaching purposes, Python. All right, now here's the trick. When you go, and you can obviously plot this again, and you're not going to see anything different, or you see it a little bit different. It overlays the plot, but I'm going to come back to this. I'm going to clear the plots here. And then let's create or use value counts. So the point of this is to do something like, let's summarize in a univariate way the values in the x column. And you can see here that we have indeed a distribution across these values. This is a series. The indices or index is the value itself. This is the frequency of that value. But we can, of course, plot this. And we can see that we get that axes plot again. And when we run this, you can see now that we have the first scatter plot with our overlay values. Now, this is not what I was expecting, right? So even when I clear the plot, you can see that the other plot remains. Now, the way to get around that is to use plot.clf to clear the frame. And when we run this again, we now get the plot as we would have expected. So this is exactly what we want, just an extra wrinkle here, an extra piece of work to say, hey, let's clear the frame to make sure that our plots don't overlap. An extra line of code, but right now I could teach around that, not a big deal. Finally, let's look at a Seaborn heat map. And again, when we do the heat map here, we're not going to get any help, but I do want to show that with what Reticulate and RStudio has built in, we also get help within this function. So you can see if you were kind of struggling to get something plotted up and you don't remember the exact parameter, you can go in and look for that here. Finally, let's plot this up. Get our axes, of course, plot.show. And I didn't clear my plot from before. So let me do that one last time. And there is our heat plot. Now, of course, this doesn't really show any proper data, but I am just working through the mechanics of how we can do plotting inside RStudio. Now, one last comment before I conclude. What I really like about RStudio is the functionality of all of the tools that come with this. I am a massive, massive fan of R Markdown and what that enables for data scientists, right? You can intersperse your text, your reports with code chunks that can be executed in the background, that you can show the code chunks and the output, or just the code chunk itself and not execute. Not only can you do that, but you can tell the engine which language you want, in this case R or Python for my use cases. And why I really, really like this is because in our Markdown, I tend to build slides through that toolkit. And the fact of the matter is, it was always clunky to me to feel like I'm in VS Code writing doing my Python projects and my Python programming. But then when I have to write a slide deck for teaching, that I would hop over into RStudio. Or if I'm managing my blog or writing articles, right, I would be hopping over into RStudio and then kind of hacking on the Markdown through the engine and those sort of things. But now, with the ability to kind of really go end-to-end with what seems like a Python project inside RStudio, via Reticulate, of course, but the plotting, to me, was the last piece that I think they're getting close to solving. My only kind of gripes, I would say, are that, plot.clf is fine. You just need to know to do that, which is why I call it out here. And then the other is a little bit of step improvements on the help to kind of show the parameters and walk the user through kind of explicit parameter definition. I'm very excited for this. If you have any comments, please feel free to leave them below. But I'm very, very excited to show this. I think this is a huge step forward for writing Python in a best-of-breed IDE for data analytics and data science. All right, I hope this helps. Thanks.